Hello, allow me to present Luna, an intelligent personal assistant for AUC students. This presentation will be conducted by my colleagues Khaled Diab, Nadeen Tameesh, and myself, Zeyad Ahmed. Our advisor throughout this project is Dr. Ahmed Rafea. First, we'll start off with a quick outline. Today, we're going to be giving an overview of the project, highlighting the problem we intended to solve and the solution we provided. We're also going to be covering some alternative solutions that already exist. Next, we're going to dive down into Luna's design and architecture, where we'll explain Luna's features, how she was designed and made, and cover Luna's overall performance. Then we'll be covering our capstone reinforcement outcomes with our deployment plan. And finally, we're going to have a demo to show off Luna's capabilities. So starting off with a project overview, we'd like to discuss how throughout our student lives, we were often faced with inconveniences regarding on-campus processes, such as special registration cases for courses, or not being able to ask about anything about something in a department because the line was so long, or generally not having enough time throughout the day to go to the various sources of information. This often led us to be misinformed or delayed in our activities because we didn't have enough information to act upon them. Our idea behind Luna was for it to be a central hub of knowledge for anything AUC related. We hope that this would solve most future inconveniences faced by students and generally improve the quality of life at AUC. One example for this could be the circumstances we are in right now with the coronavirus. With the campus access being restricted, student life, however, is still active. So students could still have questions or inquiries that they are unable to actually get answers to with most of the offices being closed down. There is the option of email, but however, it could be still slow replies. So with Luna, we now have instantaneous replies. So before we get into Luna, we need to see what else is there in the market. Anna is the first of those alternative solutions, which is a text-based AI that acts as an assistant to students in the US. Its main features include checking up on students after exams and submissions, as well as keeping track of what they have due. The other alternative solution would be the Insight mobile app, which is developed by the University of San Diego. While it does not feature actually any AI, it is still a student helper with various tools that students can use. And now, without further ado, we will get into the system design and architecture of Luna. The main features or design goals we had in mind while creating Luna was for it to be user-friendly with an intuitive chat-like structure and for it to allow voice to input or text to input. We also wanted Luna to respond intelligently to questions by its users, so we used machine learning techniques such as natural language processing to process and understand the questions. Also, with a fast database retrieval system, responses to the questions arrive near instantaneously. Finally, we wanted Luna to perform basic AI tasks such as making phone calls and searching the web.
Okay, so I'm going to be getting into the overall system architecture and the technicalities of our thesis. We designed the system in a way for it to have a layered architecture. The first layer that we have is the presentation layer, which basically consists of the user screen and the mobile OS. The second layer that we have is the speech-to-text layer, which basically converts any speech into text and vice versa. It also has our pre-processing module, which I'll be getting into later. The third layer that we have is the core layer, which basically stores our machine learning model that can interpret the intent and entities of any questions asked, which is also something that I'll be getting into later. And it also has the action handler, which can perform certain actions on the mobile OS, and the response generator. And last but not least, we have the database layer, which basically acts as the central hub for all the knowledge related to AUC, and it's stored in a database which is currently hosted on the cloud. Okay, now getting into the actual model itself. Basically, what it consists of, it's a neural network that we have used through the RASA NLU library, and basically we train it to detect the intent or the entities of a question. So what is an intent and an entity? The intent basically is the main purpose of the question, or basically the gist of the question, which is the actual meaning behind the question. And the entity is any certain names or persons or places or objects that are concerned with the question itself. So the way that it works is basically raw text input is taken in and it's being pre-processed using natural language processing techniques such as tokenization and removal of stop words. We also pre-process it in a way to determine the misinterpreted words that are often misheard, such as AUC sometimes can be heard, the word AUC can be heard as easy. So in order to make our speech recognition module as accurate as possible, we apply a certain algorithm that uses the Levenstein distance to map these misinterpreted words. And basically the model extracts an unique intent entity pair for every question, and this will be more clear as we get into the example, as you can see. So the question that we have here is, how many majors can I graduate with? Basically, this question falls under the category of academics, which means academics is the intent of the question. And the related entities in this case are many majors and graduate. These entities basically is what makes the question unique. So it can be easily mapped into a unique intent entity pair in order to be inserted into the database and get its response. Another feature that we have is, since people can ask the same question in many different ways, or ask about the same thing that can be said in different ways, like for example the schools of sciences and engineering, it can be, people can refer to it by the engineering school, the school of sciences, the school of engineering. So in order to make sure all these words map to the same word and make sure that they all mean the same thing, we use this feature as part of our neural network, which is the synonyms feature that maps all these similar words into the same word. Okay. So in order for Luna to be reachable and be accessed by many people at the same time, we implemented a simple client-server architecture. The client in this case is basically your iOS or Android smartphone that has the app already loaded onto it. You can ask a question through text or speech, and this question will be sent as a post request to the Python server. And then the Python server will return a unique intent entity pair, and this pair will be sent back to the Firebase database in order to extract the proper response for it. Now getting into more details for the backend, basically we actually have two backends. The first backend is a Flask Python server, which is currently hosted on pythonanywhere.com. It hosts the intent entity NLU model, and this is basically we tweaked it in a way in order to provide fast execution and response time, where the inquiry can be sent and the answer can be received in very minimal time. The second database that we're using is Google's Firebase. Google's Firebase is actually a real-time NoSQL database, which means that the database is unstructured. And an unstructured database will work best for our cases because given that many questions can be asked at the same time, and it will provide an easy reading and writing of data. And also a cool thing about a Firebase database is that if a question is being asked and the answer is not there, it will actually insert this question into the database in order to be checked later by moderators in order to find the proper response for it. Okay, as for the front end, since we wanted our application to be available for many people, we decided to implement it on both Android and iOS. As for the Android, we implemented it in Java, and we used an API level of 21, which covers around 85% of all devices. The important libraries that we use were Volley, which is used to handle the HTTP requests, Speech Recognizer, which is used to convert speech to text, and Text-to-Speech, which is used to convert Luna answers into speech. As for the iOS, we used Swift, and it actually runs on multiple iOS versions. The important libraries that we used was UIKit, which is basically to display anything on the screen, URL Session, which is the library used for HTTP requests, and AV Foundation, which is used for speech recognition and speech synthesis.
We decided to test the accuracy of Luna in most of its aspects using some performance metrics. So we recorded 100 test cases and tested each aspect separately using the same 100 cases to avoid unnecessary variables. When testing the speech recognition software for both the iOS and the Android apps, the results came back quite similar, with only 3% in favor of the iOS to make up a total of 77%. As for the intent entity model, the model proved to be reliable to a good extent in fetching those pairs at 71%. Also, upon feedback from Dr. Rafea, we decided to calculate the overall accuracy from start to finish in both apps, and the results came back with only 1% lead in favor of the iOS app at 73 and 74%. Last, we have the F1 score, which is used to test the balance between the precision and the recall for both apps. And here, the Android came up a little shy of the 70 mark at 68%, while the iOS kept its consistency with a little over 70%. Here are some examples of the test cases and how we calculated the accuracy. As shown in figure 5, we inserted all of the test cases into a data frame on Python, and then we compared the actual sentence to the predicted one given by the NLU intent entity model. As for the speech recognition, figure 6 shows that we applied cosine similarity to see how similar the predicted output would be to the actual utterance to test the accuracy of that speech model. And next, we have our plan for Luna's community deployment. So as of now, early versions for both the Android and the iOS apps have been sent for release on both the App Store and the Play Store and are pending for confirmation. We have decided to make both apps completely free with no ads or methods of monetization whatsoever, since Luna's purpose is to serve the AUC community. We also would like to mention that for safety purposes, to use Luna, people don't need to link their AUC accounts or credentials. And also, they don't need to use any login or registration methods for that matter. As for Luna's long-run maintainability plans, it is important to note that Luna requires both users and moderators. So thanks to Luna's built-on database, users can feed Luna new questions that it isn't familiar with, and Luna will add them to its database. Here's where the moderator's job come in handy. Moderators can view these new queries and train Luna to understand these questions to cope with the ever-changing data and be able to better help the AUC community. As for the marketing, we intend to promote Luna in the community using social media and word of mouth. A final note on maintainability would be that in order to help Luna grow, individuals that are interested in acting as moderators are needed. Finally, I would like to shed some light on some of the limitations that we faced during the development of Luna and end with some plans for its future. As you all know, Luna requires a big database to accommodate for the questions that can be asked by AUC students. Therefore, data gathering was an integral part of Luna's development. And well, needless to say that the current situation of lockdown and the according policies of campus restrictions made it hard to gather the data from AUC offices, and we had to resort to other less efficient methods. Moreover, the overall progress of the project was a little bit impeded due to the sudden shift to online platforms for progress sharing and communication as a whole. Last, we would like to mention some possible future improvements for Luna. One would be to integrate Luna with AUC platforms, such as the AUC mobile app. Another improvement would be to work on Luna's assistant capabilities, such as to-do lists and others. Also, a tedious but huge improvement would be to incorporate the Arabic dialect into Luna to make her understand both Arabic and English. As always, thank you all for listening, and the demo will begin shortly.
Okay, so I'm going to be presenting the demo and be giving like slight comments about all the functionalities. We edited the video in a way so we can show all the functionalities of Luna on both the iOS and the Android app, so we can show all of you that it's fully functional. And yeah, I'm going to play the video now. Hi, Luna.
Luna, reporting for duty.
Can I reserve the rugby field?
Students can reserve the university fields through the Office of Athletics.
When does the accounting office open?
The accounting office is open from Sunday to Thursday, 8:30 a.m. to 4 p.m.
How many accreditations does the university have?
AUC has over 17 different accreditations from various institutions.
Thank you. How rude. Redirecting to browser. Here's the number. Here's what I found.
When do final exams start?
Searching.
How do I declare filmology?
It seems my auditory sensors are malfunctioning.
How do I declare filmology?
I do not have an answer for that.
Okay. So as you all saw, Luna is able to respond to both speech and text queries. It's also able to respond to, perform some action handler tasks such as open the browser, to search up certain keywords, or to provide you with certain numbers that you can call with, such as the AUC clinic. And lastly, it also responds to questions that do not have answers in the database. And in this case, it actually returns it to it inserts it back into the Firebase database under a category named unanswered, where you can find the question that I just asked, how do I declare filmology, is inserted into the database for the unanswered one. So any moderators or admins taking care of Luna can see why the question was not answered and maybe add the answers into the database. All right, so this concludes the end of our presentation. If you have any questions, please let us know, and thank you so much for watching.